When you're designing a modern connected device for edge computing or Industry 4.0, there's a lot of complexity. Processing power and memory management, connectivity and security, power management and peripherals, there's just a lot that can slow down development time. But if you use an embedded system on module or SOM platform, many of those challenges are already solved for you. And that's what we're exploring in today's Tech Chat, sponsored by Mouser Electronics. I'm Daniel Bogdanoff, and I'm joined by Andreas Burghart, Senior Product Manager at Digi International, where he's responsible for OEM solutions. And I'm also joined by Mena Roumbakis, Product Marketing Engineer in the Microprocessors Group at ST Microelectronics. Andreas, Mena, thanks for being here today.
Yeah, happy to be here. Thanks for having us.
Now, I saw that you brought a bit of a roadmap of where you're going with this and where you are now. Can you pull up that slide and let's kind of talk about just the state of the union and where you want to be going with this program?
Yeah, so quick intros, I guess. So this is the roadmap for it is also our MPU product portfolio, but then Digi's done a great job of pretty much taking all of our devices and putting in a module. So you can see where we came from, where we're going. The MP1.5, MP1.3, those came out 5 and 2 years ago, respectively. We've currently released the MP2.5 with an MP2.3 coming. And then obviously we're looking to the future with our next generation product as well. And then you can see that the Digi has created SOMs around all of those products. So Andreas, if you want to comment on those.
Right. We started a few years ago to partner with ST Microelectronics, and it's been a great partnership so far. So first device we came out with was the ConnectCore MP1.5 using ST's first generation of the microprocessors, the 1.5. And then right after we were part of the launch with the MP1.3, which is a great product, entering that lower space of the compute portfolio. And we're really excited about the MP2.5. ST is just launching that to mass production. And we are there with the SOM. The development kit is available today. We're shipping as the first development kit for our MP2.5 SOM. So great platform, lots of good features. So really excited about that. And we work on the future platforms with ST. The MP2.3 is coming, as Mena mentioned. And next generation products are in the pipeline as well.
As you've been developing the next thing and this one, how much has it been just let's bump the processor speeds and maybe add a core? And how much do the peripherals start to matter in that extra connectivity or even like NPUs that we didn't necessarily think about 5 or 10 years ago?
Yeah, with the MP2 specifically, we have quite a few accelerators in addition to the cores. So MP2.5 is single and dual Cortex A35 base, but we have a lot of accelerators around it. It's the first STM32 device with a true hardware-dedicated NPU or neural processor unit for AI acceleration. It has a 2+1 gigabit Ethernet TSN-enabled switch. In addition to that, there's PCI Express, USB 3, lots of connectivity options here. So yeah, we're running an operating system on the cores, but then we have these accelerators that sit next to the device to really hone in on applications and be in that low-power edge application use case.
And I think the next slide has some more on that. So maybe we hop to that one and talk about a little more about this connectivity and what sort of use cases and changes are you seeing in how people are starting to develop embedded and edge hardware?
Yeah, the STM32 MP2.5 family has a lot of great features, and on top of what the one generation provided already with all the accelerators. It's a very versatile device. I mean, it has a lot of updated interfaces, USB 3.0, PCI Express, so it makes it suitable for a wide range of applications. It has great multimedia support with the VPU and GPU. But a few things which really stand out, as Mena said, is the computer vision capabilities with the camera interfaces feeding into the image signal processors and then into the NPU for inferencing. So that really builds that complete vision pipeline in the device to accelerate these vision applications. And from the SOM perspective, I mean, what we do here is we group the processor with the high-speed memories to take away that complexity in an embedded design for our customers. And then as Digi, we always have that wireless option on board with the Wi-Fi 6 radio on this device combined with the Bluetooth 5.4. So you have full connectivity on the SOM up to the antenna connector, actually. So all that design complexity for wireless designs is taken away from customers. And it's fully certified for global use. So that enables wireless communication right out of the box for our customers.
So with this, SOM or the system on module technique, how does that certification transfer over to the actual, end device?
It's pre-certified as modular certification, so customers can leverage that certification for their end devices and for all the different regions, right? For North America, for Europe, and Japan, Australia, New Zealand, some others. So it can be reused. Of course, you have to do some spot checks at the end for your product, and you need to go through final product certification with your device. But it takes away a big chunk of the certifications with that pre-certified SOM. A lot of cost, a lot of paperwork, and a lot of time in these projects.
Yeah, and we at ST see that as a big benefit, right? The Digi does all the heavy lifting on this module. The DDR layout, the initial boot process, the Linux image, and then also the wireless connectivity with the certification is a big benefit to our customers.
Yeah, I saw there was like a Yocto distro that I think we'll talk about a little bit later today. But this thing is tiny also. Like I would expect much larger than this. So that's pretty impressive to be able to get it to 30 by 30 millimeters.
With the Wi-Fi on board, I mean, that's the key thing, right? That takes up quite a bit of space, and that makes Digi pretty unique in the market with a tiny SOM like this and still having all these capabilities. What we also have on there is actually a TPM ST is providing for advanced security. So you can enable a TPM as well on that product and use that for your security functionality.
So with all this new capability and the machine learning, are you seeing it going into like industrial equipment or consumer gear? What sort of things are you building this for?
The device itself is a general purpose MPU, but as you can see here, it does very well in the industrial space. You can see the extended operating temperature and the lifetime of the device as well. ST's committed to a rolling 10-year longevity commitment. So every year we extend it by another year. So we're committed to 10 years from now, and next year it'll be in another 10 years. So we're committed to that rolling release schedule. And then Digi does a great job of one of the key specs here is they spec ambient. So as a semiconductor company, we spec junction temperature on our devices. That's the -40 to 125C. Digi takes that a step further, and they'll spec ambient, which is a lot easier for our customers to design around. And you can see that's -40 to 85C. And then the devices themselves geared to that long-term release availability. And hopefully I'm not stealing Andreas' thunder, but one of my favorite things about having the module is it takes the procurement aspect of it for our customers' point of view to the next step. Right now, you're sourcing a single part. You're not nearly as concerned about DDR longevity and availability, because that's one of the things that moves quickly in the industry is the DDR memory requirements as they move from older to newer technologies.
And this is running DDR4, I think. So it's already using pretty up to date, but it does move quick.
Absolutely. So the purchasing aspect is a big point we see with many of our customers, especially going through that supply chain crisis, right? So they're really wanna purchase one part. We take care of all the maintenance of the SOM, and it's a single item they're purchasing. But I want to talk a little bit about the longevity too, because that's very important for us and our customers. We deal a lot with medical OEMs and industrial OEMs, and they have long project timelines to get things to market. They go through lengthy approval, through all the certifications. It's not an exception that it takes 5 years to deploy something in the market, especially in the medical space. So with having that extended longevity, that makes a difference, and that's what our customers expect from us. And having this on a rolling scheme, I mean, that's very nice, right? So as soon as ST is not renewing the longevity, you have that 10-year runway to redesign and go to the next generation. So that's really exciting to have that rolling scheme on the longevity and not just like a two-year window where you have time for your last time buy and last time ships.
Yeah, I've done more lifetime buys than I would like to. So longevity would be a big part of part selection for me. I'm curious, what happens below minus 40C? Do electronics start to get weird as it gets ultra cold?
It might not boot anymore. That's the most tricky part. Once it's running, it warms up. So it's
it
usually
affects
fine.
the timings. Yeah, it affects the timings of the signals inside the SoC. And if timings are misaligned, you'll get boot failures, hard faults, things like that.
Okay, had to ask. I've only been that cold once, I think, but the car was still working. So I also see security here, and I know we'll probably dig into this a little more, but security is such a tricky thing, especially when you're looking at 10-year windows. What is your kind of philosophy of design around security?
I mean, from the ground up, we design our devices to be secure. We're in a lot of applications where customers, thankfully, do care about security. So our device, we have CSIP Level 3, PSA Level 1 certifications. Both Cortex-A and Cortex-M cores both have Trust Zone, and that's a software security feature. In addition to that, we have on the MP2, the RIF, the Resource Isolation Framework, and that's more a hardware-centric security feature. We do also provide that secure provisioning ecosystem, and all this is to enable those secure applications at the edge, right? You have AI models on these devices potentially. There's secret information, whether that's keys or certificates, and just the use cases. You might be in a lock entry application where you need to make sure the device itself is secure, and that's at the bottom level. Then Digi takes that to the next level and adds a layer of security on top of that as part of their ecosystem.
Yeah, Digi has a strong focus on security. The STM32 MP2 5 provides all these essential features required to build a secure connected device with the root of trust for secure boot and many other features. And we use that as a base, as a hardware anchor for our Trust Fence security framework, which we have started something like 10 years ago. We have started to invest in security, and we're providing a complete security framework for our customers, which has all these key and essential security features pre-integrated, and making it easy for customers to enable them for their products.
Yeah, I know if I'm implementing something like this, I want some like turnkey security. I don't want to have to be trying to implement my own, certifications and there's everyone's responsible for security, but having things a little bit turnkey is very helpful here.
It's very complex to keep up with the security and to implement that. And then you get software updates, you start reintegrating that. So with Digi embedded Yocto and with our Trust Fence security framework, you get that all out of the box pre-integrated. So that's a complete, Trust Fence is a complete device security framework that simplifies securing connected devices and helps OEMs to be compliant with the new cybersecurity laws and requirements, as for example introduced with the EU Cyber Resilience Act. So these are very important topics today. So we're right on with the Trust Fence offering, and we get a lot of interest in the market that comes to us because of our security angle with that Trust Fence feature set, but also with our complete Digi embedded Yocto operating system, which further integrates, besides the security, many other building blocks an OEM needs to build the final product. On the UI side, on the power management side, a lot of tools around that, and it's all fully validated and tested on the different platforms, providing really a robust base to get started with the application development. And further on the security, I mean, this is security features, right? So that's what you need to build a secure product. But then it starts with the maintenance. You need to keep that product secure throughout that entire product life cycle. And we started to also provide security services to help our customers to maintain the security of devices throughout the life cycle. And that includes detecting vulnerabilities that affect the customer's product with their specific software bill of material, material and the packages and configurations they're using, and then get patches in place to fix these vulnerabilities and go over and over in circles, right, through that security maintenance cycle throughout that entire life cycle of the product. And these are subscriptions we are offering since a few years and helping customers to take away that burden of maintaining the device throughout that entire life cycle. Everybody is resource constrained, right? And we are, as a vendor, providing that as one of the key offerings as part of our ConnectCore SOM solution.
Well, that seems super useful to have a dedicated distro with, devs and updates. And I assume this does over-the-air updates as well, right?
Yeah, that's actually part of our ConnectCore Cloud services. That's one of the features. But you're right. Of course, if you have fixed the vulnerabilities in your software image, you need a secure way to deploy that to your devices which are out there in the field. And that's what we provide with the ConnectCore Cloud services. One of the key features indeed is the secure over-the-air firmware updates. And that's working out of the box with all the partition tables and the flashing and all the things you need to be aware of to update a device securely and reliably in the field. So that's covered in our services, plus many other features, right? So you get the data from your device through a secure connection into your end application. You can monitor your device health in the field. You can configure it remotely. You get even access to like a command line interface and just get onto the device and do some debugging, especially important in the early phases. And that's all working out of the box with our ConnectCore SOM solution. And a very nice addition to that is you have APIs for all the functionalities. So that's what OEMs need. They want to build their own applications. They don't want to use our UIs and our remote management platform, but build their own UIs and applications. And we have APIs for every single functionality offered by the ConnectCore Cloud services. So OEMs can integrate that in their own remote applications, but also other business applications they might be using already.
So you have the APIs in place and people are able to turn this on and connect it up with their systems. You mentioned earlier there was a neural processor unit in here. How good is that? And can you explain a little bit the TOPS metric for NPUs?
Yeah, so like I said, this is the first STM32 device with a dedicated neural processor unit for that AI acceleration. And we spec that at 1.35 TOPS. To be honest, the industry probably needs to do a little bit better on how we spec these devices because it is very specific to the underlying hardware. So the type of model you bring to the table, is it optimized to run on this AI accelerator? And as part of that, ST does provide a lot of that ecosystem around enabling that feature. And then on the hardware side, as you can see here, we have the GPU engine that can support up to 1080p resolution, multiple display outputs, but maybe more importantly is that MIPI CSI2 camera interface with an imaging pipeline. So we take that data input in hardware very quickly and efficiently, run it through that AI accelerator to help enable fast inference times, and also the multi-uses of the device. So you can still be driving the display, you can still be running Linux and doing other interesting things while you're running these AI engines on the device. And again, we spec it at 1.35 TOPS, but I would always encourage you to get your hands on the hardware, start playing with it, and use the software ecosystem that we have around that. And one of the features that we have coming out in the very near future is the ability to tweak that imaging pipeline. So we have a software tool coming to help you turn the knobs and the different options in that ISP to get the full use out of the device. Because what you might record or the image inputs that you're getting that for visual input might be different than what you might be targeting for AI input, where you want more contrast that might not look pretty to the eye, but makes the AI engine more efficient.
So let's talk briefly. Say I have a AI accelerator chip, I have an NPU, and I have a camera. You're saying having some extra processing in between can be really valuable, and you don't want to necessarily just, send a raw camera feed right into an NPU. You want to do some engineering on it first.
Yeah, and that's really the realm of the people training the AI model and the engine behind it. So Whereas we want a nice clear picture that has nice contrast with the colors. An AI model might prefer something closer to a black and white with more contrast between edges and things of that nature. We want a nice smooth 15 to 30 frames per second, if not more. The AI model might work better at 5 frames per second, and it'll be more efficient running at that as well. So we give you the tools to kind of tweak and modify that so you can really target your specific model and use case in the application.
It's important to get that image stream which you feed with the cameras into the system actually ready for inferencing in the NPU. And the ISP takes that work. It does the color space conversions, as Mena mentioned, or even resizing or grayscaling, just to prepare that image stream for perfect inferencing in the NPU, which then is doing the object detection, the facial recognition, and other visual operations.
How power hungry are MPUs? Like, when you say, oh, it has Wi-Fi 6 or it has, gigabit Ethernet, I can kind of have, rely on some experience and say, okay, it's going to take so much power. How much does an MPU use? Is it kind of on par with a normal processing core?
Yeah, so we have specs for the SoC itself. Obviously, a module like Digi's will include other components like the DDR and the Wi-Fi. But the processor itself, the MP2, is very power efficient. Again, we chose those 835 cores because of that sweet spot between performance and power consumption. We're on a very power efficient processing node. In full run mode with the Cortex A cores running at 1.5 gigahertz, the M33 coprocessor running at 400 megahertz, we're still consuming less than half a watt. Granted, you might be adding other capabilities like the GPU, like the AI engine that could maybe bump that up a bit, but you're unlikely to be in that full tilt highest speed for a very long period of time. So a half a watt or less would be a fairly common scenario for this device.
Power efficiency is a great topic, right? And I fully agree with Mena. It's a very efficient device, the MP2 5. There's a lot of AI accelerators out there that draw a lot of power, but you often don't need that processing power in the AI engine. You can cover a wide range of applications in that mid-range with a very efficient device like the MP2 5. And power consumption is key also for the OEMs and customers we are working with. In many cases, if you're building battery-powered devices, right, like handheld devices which you carry around, you want to last that battery for a long time. And the MP2 5 is very efficient, giving us the opportunity to create a very efficient SOM as a total, and then the device makers to create efficient products.
Yeah, half a watt's very manageable. Who is starting to use these things? I know, like, as you go to develop and you're looking at roadmaps, you're trying to find target applications and customers. Could you talk a little bit about where you've seen these be used and why this, what are some of the killer applications for it?
Yeah, the one thing to note is the STM32, all of the MPUs, but the MP2 specifically, these are general purpose processors. So they do see a wide range of application and use cases. We talked about a little bit about the how they were really good in the industrial space because of the longevity and extended temperature environments that we can withstand. But to just highlight a few key applications, the industrial and factory automation, smart homes where you need some of that added connectivity, and then the smart city infrastructure we see around us. That can include anything from gateways, white goods, power grid and EV applications. And then with that AI engine, we can take that a step further, anomaly detection, people and object recognition, traffic management, and smarter energy management as we build up this more advanced energy grid in not only in the US, but around the world. And again, all of that is available because of the hardware acceleration that we have on the device, that low power feasibility and capability around the 835 cores in that power efficient processing node.
What are some of the things that you see people kind of across industries needing to rely upon, features, capabilities, and what are some of the things that are maybe unique to one or two of these different application spaces?
So the device is it's very flexible. So a couple of the unique features, not everybody has data scientists or the capabilities of doing their own AI models. So that might be unique in some regards, although we are seeing a lot more people wanting to test that use case. We have that 2+1 Ethernet switch, which may or may not be beneficial to others. So different components of the device are more beneficial than others depending on the application. We try and be flexible, right? We do have a 1080p video encoder and decoder. If you're not playing back videos, that you probably won't be using that portion of the device. But again, we try and be flexible and give you the most breadth in terms of potential use cases using the STM32 MP2.
So kind of turn on what you want and turn off what you don't. Go ahead, Andreas.
Yes, exactly.
The switch is a unique feature for industrial automation applications, right? But as Mena says, it's very versatile. With the VPU and the GPU, you can drive kiosks and point of sales terminals, and of course the computer vision pipeline with the ISP and NPU is enabling all these computer vision applications, which we see pop up in all these markets. It's going slow, right? But people are looking and are interested and want to be future-proof, so nobody wants to miss the train. We see not many end applications hit the market yet, but everybody is looking at it. Nobody wants to miss the train, and they want to have that capability in the device for their future products. They might want to turn that on in a later stage of the product life cycle to enable things like predictive maintenance or other things, and build services on top of that in the application space for their customers. So they want to have that future proving. So it's a very interesting feature in the MP2 5.
So when it comes to the industrial space, and we're talking about object detection, where is that particularly useful? How are people using that capability?
So that's a key target application for this platform. Entry-level industrial smart cameras used for quality control and other inspection tasks. Smart cameras can be used for defect detection in a production environment or in logistics to facilitate automated sorting and packaging processes by scanning barcodes and labels and things like that, or diagnostics devices used in medicine and laboratories for analysis tasks. So these are all vision applications, and we see them perfect fit for this ConnectCore MP2 5 device.
Yeah, I use a little bit of that for like my 3D printers. When they start to freak out overnight and I'm asleep, it'll throw a flag and pause them, and that is a lifesaver. And that's just a tip of the iceberg. When it comes to training models, we've talked a lot about inferencing, so taking a trained model and running it. Where are people getting their models from? Are they doing their own training? Are there pre-trained things out there for them?
Yeah, so that's where we try and enable our devices as best as we can, right? So ST provides what we call our model zoo, and these are open source models that are available for anyone to use. We do take those and target our STM32 devices, and that's actually true for our MCUs and MPUs. So we have an X Linux AI package, and what is that? It's essentially a Yocto meta layer. It pulls in all the resources that you need to start doing your AI development. It includes a generic model zoo. If you don't have your own models to start with, these are pre-trained models. It is optimized for targeting our hardware, like the AI accelerator that's in the MP2. But beyond that, it also includes all the frameworks that you need to pull in and example projects as well. So you can start using our open source examples on day one. And then as you kind of familiarize yourself with the system, maybe you're training your own model in the background, then you can take that model in and also have the tools necessary to be able to optimize your model to target our hardware. And around that, the open source models, we have image classification, pose estimation, facial recognition, and object detection might be two of the more popular ones. But again, those are the open source models that we make available. We obviously encourage customers to kind of bring their own AI needs and their model to the table. We also have a cloud resource. So if you have the hardware sitting next to you, we have a desktop version of the tool. You can do everything yourself on your local machine. If you want to just kind of test out, see what this thing can do, we do have a cloud version of the tool that lets you target the hardware, give you real world inference times on what you can expect for your model. And again, that's all available through our website.
And the X Linux AI layer ST is providing are fully integrated in our Digi embedded Yocto and our documentation to provide an easy start for customers on their AI application journey.
So it sounds like with the Model Zoo and some of the other things we've talked about, there's just a ton of support and resources out there for folks. Can you kind of just briefly walk me through what does the ecosystem look like kind of start to finish?
Along with the highly integrated SOM, Digi brings many advantages and additions to OEMs building products, our customers. So Digi at its core is a wireless company, and our wireless support is best in class. We have been doing wireless for over 20 years now. And not only flexible connectivity with support for whatever the customer needs, but with a solid performance that's been proven in thousands of customer installations. On this device, we have a modern Wi-Fi 6 and Bluetooth 5.4 on board on the SOM, as mentioned earlier, pre-certified. And then we also have a product line called Digi XB, which provides additional connectivity options for customers in the short range, long range, and cellular connectivity for customers to choose from and use in their applications. And then we have the ConnectCore Cloud Services. We are providing ready-to-use essential features to OEMs to create connected devices and maintain them in the field. The complete software offering we are providing is our feature-rich Digi Embedded Yocto Linux distribution, fully validated and tested with every release. It's providing a robust and stable software environment to customers, and we keep adding things, as for example, real-time extensions, container support is a key one we have added in the latest release. And then also we have a lot of design tools, including Altium designer files, reference designs for the hardware side of things, but also our Digi ConnectCore Smart IOMux tool, which helps customers to create error-free designs in time and hit their project schedule. ConnectCore Smart IOMux helps with the multiplexing of the pins, adding the features customer needs in their application to the pin of the SOM, and also creates the low-level Linux device tree configuration, which is a painful effort sometimes to figure that all out. The tool just spits that out at the end of your configuration. So a lot of the design work is done in that tool. And then we have a lot of support. You can call on Digi sales engineers to help you with technical questions during evaluation and design. And we have a lot of documentation that is available online. And really, we're investing a lot in the documentation. That's a key deliverable we have in our offering. And the Digi support on the technical side really makes a difference to what our competitors provide. So we're really partnering with companies and going on a joint journey to get them into production with their devices. And security is also built in with the Digi offering, with the Digi Trust Fence, that ready-to-use feature framework I mentioned earlier, and the many building blocks to create secure products. And then again, the ConnectCore security services to maintain that security throughout the entire life cycle of the product. You're not done with deploying the device and releasing it in the first release, right? You have to maintain that throughout that entire life cycle and keep up with the many security vulnerabilities that become public and affect your product. And that's mandated also by the new laws and cyber regulations. And the service really helps you to comply with that and keep your product secure in the field.
So it really looks like you kind of have across-the-board integration. And when you're implementing a device like these folks are trying to put together, there's a lot of things to think about and a lot of different things that have to play well together. But it's all kind of collected into one place for folks to make it a little easier for them and get their devices to market faster.
Absolutely. It's important for companies to partner with somebody that provides that overall solution. We're all limited on resources, right? And we need to hit project timelines. So there's no need to dive into any of these areas and build up expertise and train your people in doing that, right? The core expertise really sits somewhere else with the application and the services, and that is what our customers want to focus on. There's no need for low-level embedded experience or any of the lower layers in that embedded design to have that know-how and expertise and maintain that and spend the resources. So it really helps to streamline things in a company and focus on what really matters, the core expertise.
So if people want to get started with this, is there a dev kit available? What's the best way to kind of start exploring it?
Absolutely. So the development kit for the ConnectCore MP2 5, that's the latest device on the ST side with the STM32 MP2 5 processor family. We have released our dev kit that's available already in the channel with all the main distributors, and it provides that full development board with all the features pinned out for customers to start developing on that. And also, we're including a full 1-year license of our Digi ConnectCore cloud services. So you get a full 12 months off the service, and you can connect your development kit. You can provision that as part of the Get Started, and then you can start monitoring your development kit from your mobile phone or smart device. You can remote configure it. You can look at the data, and you can do software updates and things like that, playing with that service from day one. So again, development kit is available today, and you should get one and get started.
We're very excited to be working with Digi on this device. Like I said, we're pretty excited about the STM32 MP2 family. And like I said, the value add services that Digi brings to the table is hard to beat, from the complexity of the design to the added software layer and security features on top of that. It's hard to beat that combo package. And we hope our customers, if you see a big value add there, just like we do with this type of complicated design and those software resources available to you.
Well, Andreas and Mena, thank you so much for your time today. This was fascinating.
Happy to be here. This is great.
Thank you. It was fun.
You can find the MP25 dev kit and other Digi and ST Micro products at Mouser.com. Thank you to Mouser for sponsoring this tech chat. I'm Daniel Bogdanoff, and on behalf of the whole All About Circuits team, thanks for tuning in. We'll see you next time.